All right, guys. So welcome to our week 3 session. So before we will start our presentation, our lesson. Let's go through the Jira board and to see how we are going here. Let me actually refresh it. Oh, cool. So I just actually cleared like some of the tickets for ready for UAT. Like I see right now, here's the 6 of them. So I'm gonna do again and see. I'm gonna check them. But as I see, oh, okay, I see like at least one or two exercises task, which is good. All right, do you guys, all of you already set up IntelliJ and Maven and Java on your local laptops?
Yes.
Okay, because I'm asking because we will need it for today's lesson. We're gonna switching our practice from like older version online Java compiler to the local IntelliJ IDE and Java. So from now everything will be locally, like all the programs will run locally, and all the codes actually they should be submitted to the GitLab. And like right now, you will need to submit it there and also share the link to the GitLab from your code. All right, so let's quickly see the report. Okay, so it's all done today because like I'm actually started to look to them from today. Like I didn't do it yesterday. So hopefully, like more of you will submit their homework, and we will be like online, and we'll be able to finish most of the tasks until following Saturday. All right, so let's start then. Let's start our presentation because today we're gonna talk about more kind of like advanced Java stuff. So we're gonna talk about the OOP subject of Java. So it's more like when we used Java core and the simple Java operation, we didn't like use full Java like a power of like manipulating and creating the data, creating functions and all of the stuff. So like starting from today, we're gonna dig deeper to the OOP world. Like probably like most of you already heard about the OOP, or like if you work in other languages like C# or Python or I don't know, C++, like most of the advanced languages using like OOP concepts. Yeah, we're gonna talk more about that today. So here's our agenda for today. So first of all, we're gonna talk about what the OOP stands for, explanation of classes and objects in Java particularly. And this is actually gonna be the most important part of this presentation, of this lesson, because it's really critical to understand what the class is and what the object is and how is the different class from object. It's really important because like once you will understand this part, you can consider that you know OOP like at least in 60-70%. This is kind of like fundamental of OOP in general. So after that, we're going to talk about the tips for creating classes in OOP. Then we're going to talk about the methods and data, like type of methods and what the good method should be. And actually the other stuff like inheritance and encapsulation, abstraction, and polymorphism, we're going to talk about that in Thursday. After this, after we finish talk about the classes and methods, we're going to do like some coding exercises. Pretty much that we did on Saturday. This will be like the same format. I will give you some exercises after these topics. And you will need to submit your answers in a Slack, and we will just compare like each of your approaches, how you guys did that. So yeah, So be concentrated, because like if you all missed few topics from here, from today's presentation, you won't be able to implement these exercises. All right, guys, let's start. So what's the OOP? So OOP stands for object-oriented programming, right? So basically, it's a way, it's kind of like a type of style of creating a program where like you kind of separating the whole program to separate objects, and each of these objects, they are closely interacting to each other. So basically, you're kind of dividing the whole application to the smaller parts, and which is actually like opposite to the procedural programming methods, like types, where like basically the full program is like basically one file, just like a bunch of code in one file, and it's not like really like separated. Like once, like in the history, actually, like all the programming languages started as a procedural. They all use like procedural style. Like even a C, like which is like original C language, not C++, it's also using a procedural programming concepts. And I believe like JavaScript, JavaScript right now supports some OOP concepts, but I think originally it was also kind of use like procedural style of writing of programs. And yeah, like some of the advantages of the OOP that it's easy to divide the responsibilities, and it's easy to divide between, like, let's say if you have like a bunch of developers, right? Like maybe like across the city, across the countries, you can just separate to the specific parts and just give like separate like responsibilities, and it will be easier way to implement it. Yeah, and as I said, most of the like popular programming languages like nowadays, they all using OOP concepts. All right, so okay, so what's the classes and objects, right? So basically, class, in a simple words, it's just a blueprint for creating an object. Let's say you can see this picture. So this is kind of like visual illustration what the class is and what the object is. Let's say you have a kind of like a blueprint of a car, right? And you can use this blueprint and create like a different kind of cars. Like, I mean, it's maybe like Volkswagen Polo, or like a Mini, or like Volkswagen Beetle, or like any kind of like car. But the full like a model, it's actually a class. And based on this model, other cars are creating, which is basically an object. So to create an object, you will need to initiate the class. And you can like create like as many objects as you want. Like only thing you will be limited is your memory, basically, your array memory. And you can also add additional parameters to your objects, right? You can make your class more adjustable. So it will like take some of the parameters. Let's say you can specify the color of your car, right? Let's say you can, once you will initiate the class, you can specify like, okay, I want like the first object be like a green car, or the second one is a blue car, or the third one is actually a red car. Yeah, and again, like all of these objects will be basically representation, like actual representation of the class. Okay, like it's kind of in a visual representation, like in a simple words, this kind of like explanation what the classes and what the objects is. So here is a code example. So let's say this is like how we define a class in Java. It's actually have only like one integer, so it's called like attribute. like all the attributes is basically the integers, like variables or like constants. It's basically the data itself. And also classes may also have methods. So method basically it's like a small functions within the method, which like each of them performing some kind of like actions there. And this is actually like, as you can see here, this is actually the way how you will initiate an object here. Like you will need as a type for object, it will be the class name. Like let's say if we are initiating the class, like from the left side, in the main function, like we specifying the type of this object, it will be like the same class, and equal, and this is a keyword in Java, it's called the new. By saying the new, you basically asking to initiate the memory for this class, and after that, you're specifying the class name. And this is kind of like agreement that you will need to name your classes in a capital word, like in a title case, basically. And here, after you initiate it, you can actually work with it. Like let's say you can actually print the value of this attribute, right? Let's say like my class, it has a attribute, which is an integer, x, and it's equal to 5. After initiating it here, you can like interact with that and actually print this attribute or variable. Yeah, so basically that's how it works in Java and how it's all like initiated. It's like pretty similar, like in let's say like in Python, it's kind of like using the same kind of style. Like you also need to use the same keywords, and I believe like in most of the programming languages, it's kind of like common way to initiate the class here. All right, let's go next. And here's a small tips how to like for creating good classes in OOP. So first of all, class should define only one object. Let's say if you are creating a class and you want to using it as for creating cars, right? So your whole class should only have all the parameters and all the methods to configure your car, but it should not like have like a methods to configure your house or like something not relevant to the cars. So like you should be like pretty strict. And later on, once we will do like our web automation, we will use like some of the pattern is called like page object pattern, and we will separate all the methods and all the locators for specific page. And we will also use this concept when we will define like all the methods and all the locators within like one class. Okay, so what's next? Name of the class should be simple and straightforward. Like let's say you should not guess after looking to the method name what it's actually doing. It should be like pretty straightforward. So the third one, do not use the verbs in a class because class is not an action. Like once you will create the methods within the class that will like do something, right? You can use like verbs there, but like if you see verbs in a class name, it's probably like badly written class name. So number 4 is good encapsulation. We're actually gonna talk about it more in first day. So like I probably won't stop here with that because it's a whole topic. And so all methods should be structured. So basically, the idea is like all the methods within the class, they should be like pretty straightforward. The names of the methods, they all should be understandable for developers. Like, let's say if I will review someone's code, I will need to understand like what like attributes or what the methods are doing without looking to the actual logic to the code, like because it's all should be like a named pretty simple and pretty understandable way. All right, so that's it for classes, and we are going to the methods. So basically what the method is, right? Methods actually are a set of procedures used inside the class. If you guys did the homework from the week 1, you actually used already methods within the class. So you're probably already familiar with that. Basically, the methods, they kind of like actions. They may be, they actually may return something after this action, or they may just implement an action and that's it. And in this case, you will need to specify, like in Java specifically, you will need to specify the exit statement. Like let's say if it's a void, you will need to specify. That actually means that this method's not returning anything. And after actually performing the action, it will return basically a null, like no results. And if this method returns kind of value, you will need to also specify it here. Let's say if it returns a string, you will need to specify it here, or like it's the same for integers, booleans, and so on. So the thing about instance methods is like instance methods, they are using within the class. Like you cannot if you want to call the instant method, you will need to initiate the class and call this method within the class. I'm gonna show you a little bit more how it looks like. So this is actually opposite for static methods. If you guys remember our main method that we used to run our program, it had a keyword method, static, sorry, like it's actually written here. So the static keyword means that this method can be used without initiating the object of this class. So basically, you can call this method after without initiating the class and actually referring to this method within the class. Let's say in this example, right? This is like a piece of code snippet. So we have let's say in this case, we have a class which called gig, and string, like a public string name, which is empty, and also the method, it's called like a gig from the lowercase. And as you guys can see here, basically after the comments in the main method, this method actually calling without initiating the object, right? You're just specifying the class name. It's like GWEK in a capital words, which identifying it's a class. And after a dot, you're specifying this method. It's a gig in a small word. And also you're passing a string as a parameter here. And yeah, and after that you can just print the value. And actually, in Java, you can also call the static methods initiating an object as well, which is not the best practice, I would say, but Java still allows you to do that. Let's say in this example below, you are actually initiating the object as a class, right? As you see here, it has a type of the object. It's called a gig, and it's actually initiating the new instance here, after adding the new keyword. And also after that, you can also interact with that. But you guys see, in the above example, it's just 2 lines of code, and in the second example, it's 3 lines of code. And as you can see here, it's basically we just missing this initiation object initiation process. That's actually like what the static methods are used for, like, so you can like use them more dynamically without initiating and doing much about that. Does it, guys, make sense for you, or it just like still kind of confusing?
It's very complicated, I think.
Very, very complicated. Okay.
Yeah, so it took me quite a while to figure this out, really. I can say that, so the class itself, it's like a template. It's not real, right? So it's like a car, right? So what do you mean by a car? It can be anything, right? It's very abstract. But instance of a class car, that's actually the real car. In programming languages, we usually create a whole bunch of classes representing some pages, or even like a car, for example. If it was a computer game, then you would probably have a class car, which is abstract, but then you will create the real car that you would use in your computer game, let's say. And since it's real, then you have to say like, okay, the color has to be black, and the car has to be actually of a special type, like pickup or like sedan or whatever. And then the brand of that car should be this. And basically you cannot avoid like saying all of those attributes of the car. Otherwise it's not real car again. Does it make sense? No. Okay. And so this, let's say in this case,
your example makes sense, but I'm looking at this code and I understand nothing actually.
So geek basically means a person that that is proficient with computers, let's say, right? Basically it's just a person. And again, some person, right? It's not exact person. So Azat is person, myself is person, you guys all persons as well. So if you would like to represent yourself, you would say like, okay, new geek, and then you would say like a name, which would be Dennis. So in that case, you will know that like which one are you kind of talking to right now, right? So we all instances of a class person, really, or geek if you wish. And the difference between us, we all have different names. Well, sometimes actually not, but let's assume for now that the name is unique, and that's why how we can identify when we say like, hey, Dennis, like, I don't know, whatever you can ask me to do, let's say, right? So this is how we identify a person or geek based on the name. Does it make sense?
Yeah.
So this is very simple example. In real world, you would probably have like some more properties, not just the name, because we have a like first name, we have last name, we have like date of birth, we have like parents, we have like address where we live, we have like phone number, and the list can go on and on. For the sake of simplicity, in this case, we only use like a name. But in reality, usually your classes are going to be pretty big. And they actually have, they can have some classes underneath. So for example, if it's a class car, you want to go further, and the car should actually have some transmission system, right? So, and then transmission system, and then maybe like some suspension system, and all that stuff. But then at the same time, suspension system, you can elaborate on that even more. It has a lot of parts. So basically you can go all the way to like molecules or atoms, right? It just usually you don't go that far because you just don't need it, but that's how all the programming languages work. You kind of create a class and then you elaborate. So, for example, if you say like person can walk, it really means that like not the person, but person uses his like legs, right, to walk. So basically, you would ask legs to walk and not the person. So we will get there later on, but the tree itself can be pretty long. Does it make sense?
I think guys, they are confused. Guys are confusing with those two methods. That the first one is when we calling methods without creating an object, and the second class is actually a class within an object. Can you probably explain this a little bit, like more clear? What's the difference between those two? Because I know that could be confusing.
Yeah. So other examples that just come to my mind about the class and object. Let's say, imagine the template for filling application, right? Like once you want to sign a lease for an apartment, you have an application, right? And this is basically the template. And you are like, once you like wants to get the lease, you actually fill in this application. You put your name, your address, and everything. And after you filled in, this is basically an object because like you already use this template and you filled it in.
Could you please pointing out like which one? Because with the mouse. Can you point with the mouse?
No, it's not like here. It's like the difference between like static and instant methods. I'm just like telling in general like what's the class and object, like how we can like differentiate it. Okay, so in this case, like it's basically, as you can see, it's basically doing the same thing, right? It's just like in a second example, like it just has like one additional step above when it's like initiating the object. In the first example, like you're not doing that, right? You're just like calling the method. It's like after the class itself.
I would explain what is initiating the object. Because I think people, guys, do you understand everything?
Actually, no.
All right. Do you guys see my IntelliJ ID screen right now? Or you still see my presentation?
Yes, we can see.
Okay, so let's say this is my main method, right? And let's say when I say like integer a equal to 7, so what I'm doing right now, I'm just like initiating the integer, right? Integer a.
I would maybe use string better.
Okay.
So it's the actual class. It's not primitive.
Yeah. String 1 equal to, I don't know, like a car.
Or maybe use a constructor or again.
Yeah, we will like go to that like later. But like for now, so what I'm doing right now, right? I'm just like initiating the string, and basically I'm asking to initiate like to the system give me a memory to store this piece of information, the string, right? And after I initiate it, I can actually interact with it. Like let's say I can actually print this. Let's say system out print ln, and
I believe you can use sout. You can just type sout and tab, and they will replace sout with system out println. Just FYI.
Yeah, it's the short case. Okay, and you guys see, like after I initiate it, I can like basically interact with it, but I don't have to do it here, right? I can just comment it out, and I can like call the string itself within this method, and it will do the same thing. Does it make sense, guys? Like, at least in this level?
Yes.
Yeah,
Okay.
maybe you need to create a class actual with like two
Yeah, yeah.
parameters and
Yeah.
show like how it works.
I just wanted to show the what the initiation of the object means. So it's basically like exactly the same thing here, right? For like static methods, you can like call them directly from the class without initiating it. For like instant methods, you will need to initiate it only after that work with this object.
So initiating, in other words, means creation of a new instance. Because why it's important? Because you can actually have multiple instances. You can create like 10 gigs within your program, or even like million. But then the problem is that you need to explicitly ask like some particular geek, for example, to give you his name, let's say. So how do you know which one is which if you have like 10 persons? Basically, variable name will say like, okay, it has to be unique. So it will say like, okay, you're manipulating with this particular person right now.
Mm-hmm. Okay, guys. So to create like in IntelliJ, I just want to show you how to create a class. After you create the project, like in SRC file, just right-click to it, click to new, and click to the Java class. And let's name it like a test. I don't know, test.
Yeah, maybe let's stick to, I don't know, cars again.
Okay, so we have a new class right now, right? And let's say I want to create a method within the class. And let's say I will need to define the method. Okay, let's make it public. Public, and okay, let's do it void for now. And let's specify the parameter string, right? I forgot to name it. Let's say color. And the parameter name is a color of car. And let's say what this method will do, it will just print whatever you will pass in this parameter.
Yeah, sorry, just a couple of things. First of all, it's usually camel casing. In Java, it's not the Python.
Oh, yeah. Yeah. You're right.
So, yeah, like this. And the second of all, if it's method, then it's supposed to be a verb. So method means action.
Yeah.
So if you want to like print color, then it has to be like print color,
Mm-hmm.
right? Otherwise, if you call it without verb, if it's noun, then it means that it's some property of that object. Let's say color would be just
why you didn't use the static, public void, but not public static void?
So because it's not main method, it's when you declare static, it means there is only one method can exist. So if you declare like static color, you say that all your cars can be only like white color.
Got it. Thank you.
That's why you can, without creating a new object, you can interact with the color, because you know that all the cars that you create, they're going to have white color for sure, because it's static. Otherwise, if it's not static, then it means every car can have its own color.
Okay.
Mm-hmm. I mean, you see, if I will specify static here, this means, again, it will be like static method, and I will be able to call this method without initiating it. Actually, I can like show it to you right now. Let's say, okay, I think I finished here. I actually don't know why it's giving me the error, but okay, let's leave it as it is. let's delete that. All right, so we have a class, right? And within this class, we have like one method, and let's interact with that class. So first of all, let's initiate the object. So the type of the object will be the class itself. So that's why we call it cars. And the object name will be like car number 1, right? And after the equal, we will initiate new instance calling like a new keyword. And here we will use a class name. Right? So, all right, so now we have a new object which called car1. And this is an object of representation, this like a car class. And right now, after that, what we can do, we can actually call this method within this cars class.
You have a typo over there. What's that? In system print. It's traducing.
Oh, yeah.
And to be precise, it's better to name classes in a single, not the plural, but it's supposed to be like a single, so it should be like a car instead of cars.
Ah, yeah. Using the best practice. So we'll not rename it here.
So, and maybe just for convenience, let's say like Azad's car, so we know it's like your cars, and we can actually create my car. And I know for sure that both cars have different colors.
Mm-hmm.
So your car, let me guess, is blue color.
Yep. Okay. So now we have a met object, which is like my car, right? And it uses the cars class. And right now we can actually use this method, which is called like print color. So to do that, we are calling our initiated method, which is like that car. And to access the method within the class, I will need to click type dot. And you see like it's already pre-populated the methods I can use. Like the rest of the methods here, they are like built in a Java like standard methods. But the first one, it's actually my custom method. I'm calling it here, and as you guys remember, it's actually pre-populating like this method. It's accepts one string parameter, and I actually can pass my car's color, which is a blue, right? I'm wondering why it's.
Yeah, you rename so the class name has to match with the file name. So you need to rename the file now. It's still cars, the old one.
Yeah. Okay.
In Java, it's pretty strict.
All right. So now the file name and the class name are matched, and that's why we don't have this error. All right, and so we have a program, and it's actually calling the method, and this method actually printing the color that I just said, right? And let's try to run it. And as you guys see here, it's printed my set color, which is a blue. And right now, what we can do, we can actually initiate another object, right, using the same class.
Yeah, maybe the only thing, maybe instead of like print color and passing it, maybe it's better to save the color itself in the constructor.
Yeah, we can do that.
Because basically your car doesn't have any color really. It's like something that you pass from the outside.
Yep. Actually, I didn't I didn't went to the constructor topic, which is actually like the next slide.
Oh, okay.
Yeah. Do you guys like have any questions? Oh, actually, let me give you one example, right? If I will make it static, as you guys asked why I didn't do that.
There's a typo.
Oh yeah. So right now this method is static, right? And I can still I can still call it. Yeah, it still works, right? But the thing is, like, I don't have to initiate it. Let me just comment it out. When you comment out the code, it's actually, you're just basically saying like not to run it. And right now what I can do, I can use the class itself. And all right, let me try to run it. And here we go. So you can see, like, I didn't actually initiate the object. I just referenced to the class itself. And under this class, I just referenced to the method in the class.
And the hint here, you see this print color now is in italic mode, right? So it shows that it's actually static class. So IDE basically has a lot of clues for you, like everywhere, different coloring, different like italic, bold, or regular. Well, you need to get used to it, but this is just for developers really, so we can understand like how come I can call this method without having an object.
Yeah, just make
So now we can create a new car with white color, right? For example.
We can. We like just can reference. I mean, do you mean like an object of a car or just like another car?
No, Denis said that if we choose static, we can't use different colors, only one.
Yeah, that's the question I wanted to ask too.
Yeah, I think the whole implementation is a bit not like how it's usually done.
Yeah,
because
yeah.
Here we really ask car to print the color that we pass. So car itself is always the same, but the parameter that we send, we can send different parameter. And in reality, usually you assign those colors when, let's say when you purchase a car, you know that this car is blue and another kind of car is red. So basically when you purchase a car, now it's your car and it has blue color no matter what, right? Unless you paint it with a different color. So instead of like passing this parameter from the outside, the car itself would know what's the color for this particular car. But I think it's the next slide. So
Yeah, we actually like just calling it blue, but we're not saving this color within this method. Yeah, that's why it's not saved. And yeah, the next slide. It's actually, here's another type of methods. Like we already talked about the instant methods where we will need to initiate the object. And we also talk about the static methods where we don't have to initiate an object and call it. And this is another type. It's called a constructor. So the different thing here is like sometimes when we initiate the method, right? I mean, this is nice that it also has a car class, so it will be like a bit easier. In the like once we will initiate it, we can like pass these parameters like a model year or like model name or like a color in the initiation level, and it will actually like save this parameter that we're gonna send here. So you guys can see here. Here's like here's a method called car, and it has two attributes. Like the first one is the model of the car, and the second one is a model name. And this method, like as you guys can see, it has the same name as the class. It has a car, so it's actually did in purpose. So like the compiler will recognize this as a constructor, and it takes these like two parameters, like a year and the name. So as you guys can see here, like in the main method, like in the initiation level, once we will initiate the car, calling it new car, right? We also passing the year of the car. It's 1969, and the model name, it's actually Mustang. And after that, it will save these parameters, and we actually can call these parameters like separately because it will be saved there. Okay, let's adapt it to our created cars, right? So let's say we will need to create an attribute and call like string color, right? And let's say we will need to create a constructor as the same way as it is implemented here. So we just say like a public car, so we don't specify the return type because it's a constructor. And here, like as a parameter, let's say it will accept string car color, right? And yeah, so basically color will be equal to car color Let me just check that I didn't forget anything. Looks like it looks.
Yeah, year, I think.
Yeah, let's say year.
I have a question.
Uh-huh.
Should the name of constructor be always similar to the name of the class, or is it just an example?
It's always
It has to be, yes, correct. You can actually have multiple, as many constructors as you want, not just a single one.
So how the name of many constructors can be the same as the class if there are many constructors?
Yeah, so you can have multiple constructors, but the parameters that they accept have to be different. Can you, Azat, maybe create another one just with the, I don't know, with the car color?
Yeah.
And by the way, the property that you declare on top by default, since it's encapsulated, it's going to be private, so you won't get any access to them.
You mean the
field? No, fields on top, like color and year. So you won't be able to actually see them. It has to be public, yeah.
Public, okay.
Yeah, if you don't declare anything, it's private, which is the way it should be in OOP languages.
Yeah. Which will be like in our encapsulation topic in the Thursday. All right, guys, let's create for now just like one constructor just to make sure like it's working. So you will just understand the logic in this level, right? All right. So what we're gonna do now We are gonna comment this out, comment this back. And right now you see the IntelliJ IDE throwing me the error, and it requires me to pass additional parameters like in initiation level, right? So I need to pass the color, let's say.
Yeah, so by default, if you don't create constructor, you don't have to say anything. But since we created constructor, now we are forced to use it every time. When we create a new object, we have to use it.
All right. And yeah, so after initiating it, we can, so the blue actually is saved within this object. And if I want to check what the, let's say what the color assigned to this object, I can just like call it as an attribute within this object. So let's see if it works. Yeah, so it works. And as an addition, I can say like that car has right, and let's say year. Should we add space here? All right, so let me print it. Yeah, I forgot the space here.
And another one after blue, before color.
Oh yeah. So as you guys can see here, like these parameters, they actually saved within this this object, and we can like easily access it. And let's say if we will create another object and call it like Dennis car, so it should be the same initiation, like new car. I think yours is red, right?
Mm-hmm.
Both cars.
Yeah,
And
2012.
2012.
Oh, it's an integer, right?
Yeah. And the same. So all we need to do is just change the reference object here and call it.
We can actually store owner's name as well.
Yeah, we can also do that. We can like basically pass like any parameters here. And
because again, you can expand this class. Cars have a registration, due date, right? And like list of drivers, let's say, who can drive them. And a lot of like horsepower of the engine and a lot of things, right? For simplicity, we only use these two, but it's just a matter like of what you need.
Mm-hmm.
If you play some computer game like Need for Speed, let's say, those cars, they have all of those things that we mentioned.
Mm-hmm. And
I'm sorry, for a complete understanding, you can create several constructors in one class, right?
yeah.
Yes, you can.
Let me do it right now. So let's say current constructor, it requires 2 parameters, right?
Yeah, let's create another one with owner. So you cannot have a constructor with the same parameters, which is like of type, like string and integer. You cannot have any other ones with string and integer. Well, you can have with integer and string, that would work, right? Or you can create with anything else or even empty. That will work as well.
Mm-hmm.
Because sometimes, let's say you don't have like owner if it's like brand new car, right? So at the time of creation of a new car.
All right. So we have like a new concept.
Sorry, guys. So at the time of creation of a new car, there is no owner, right? You will know the owner once somebody buys the car. But at the same time, this car has color and the year. It's known information, right? But just not the owner. Is it clear, guys? So your program can be, if you write some software for registration, like DMV software that registers those cars, you would just leave it blank for now. And once somebody buys it, you will update your car and say like, okay, this is the owner now. Does it make sense?
Yes.
Yes. And the name of the second constructor will be the same, right? Car?
Yes.
Yeah, that's the deal with constructors. They have to be the same. They have to match the class name. So you see, it's like bright yellow color. It actually shows you that it's constructor.
Yeah. Actually, if you worked like any other programming languages, like let's say in Python, it will, like, the logic is different. It will have this like keyword which is called init.
Can we just add the second constructor to the first one? For example, string car color, int car year, string car owner.
Yeah, we can.
Okay.
Yeah, you can actually even call them from one another.
Like, sometimes you want this class be more flexible, and sometimes you want to call this class without passing the car color and car year. You just want to pass, let's say, car owner, right? Or you just want to pass car color without car year. You want this option. In this case, you will need to create separate constructor for it, because otherwise it will require for you to pass these two parameters because they're not optional. I mean, there's like you cannot set like a default parameter in Java, like as you can do like in other languages. So to do that, basically you are forced to create like another constructor for it. All right, so as you guys can see here, we created another one, and let's initiate it.
Let's create, I don't know, Evgeny's car.
Yeah. Car equal to new.
And for now, we only know that that car belongs to Evgeny. So basically, we only know the owner. So in order to get the details, we actually have to ask Evgeny first, and he's on vacation, so we cannot ask him right now, let's say, right? Only thing that we know is that he has some car.
Mm-hmm.
Does it make sense, guys?
Yeah.
So we're kind of saying like, okay, we know he has a car, but we don't know the details, year and color. Once we get to know those details, we will update his car. So now his car will store all of those values. Make sense?
Yes, and because we input only one attribute, it identifies that it should go under the second constructor, right?
Yeah, exactly.
That's exactly how it works. Yes. It actually shows you like. Actually shows you that you see that when we create a Evgeny car, it shows car owner in a very gray, tiny text over there before the Evgeny name. Can you see that?
Yes.
So that's exactly how it matches based on the parameter type, which is a string. And that's why you cannot have two constructor with two strings, let's say.
Mm-hmm.
Because it cannot know like which one is which.
Yeah.
I have a question.
Mm-hmm.
Yeah, so in Evgeny's example, we won't be able to add year and color, right? Only the owner.
For now, yes. Well, actually, Azad, can you please put it on a breakpoint right after we declare Evgeny's car, so we can actually see all of those objects that are in memory. And this is maybe something that you haven't seen yet. So you see at the bottom variables here, it shows you all the variables that this class has, which is main test class and everything that we have within the main method. At this moment, it stopped before we declared Evgeny's car. So you see, we already have Azad car, which is color blue and year 2005, but owners, you see, set to null. We never said like who is the owner, even though we kind of know that it's Azad, right?
Yeah, let's.
But we never said that, so it's like set to null. But if you step over to the next step, no, you can just step over. It's on the left.
Yeah, I stopped it already, so we'll need to run it again.
This is very convenient tool, debugger, and you will probably use it a lot, like while developing. You see, so now we have 3 cars because we stopped after. So we have 3 cars, and Evgeny car only has owner assigned, but not color and year. You see, year by default for integers is 0, and color is null because it's a string, so it's not empty string, but it's null means nothing.
Yeah, or like nil in other programming languages.
Question. Azad, can you please go to constructor tab?
Mm-hmm.
You see that public static void print color is not commented. Is it okay?
Yeah, because we're not calling it. Like you see, we're just initiating it, but we're not interacting anywhere.
So it doesn't call. Okay, got it. Okay, thank you.
So actually, let's update that print color now. Since cars know what the color, we don't have to pass it, right? We actually know, cars know what the color is. So every car has its own color, well, except for Evgeny. So we basically cannot call this method because, I mean, it will just break. Just color.
Okay, so I need to make it static, right?
Oh no, you need to remove static from the bottom.
From here?
Mm-hmm.
Oh, okay, because we won't be able to pass it like it. Okay, makes sense. And
so we now say that every car can have its own color, and we can print those colors.
Yeah, and we cannot call this method separately without initiating because like we won't be able to get this variable of the color. We won't be able to pass it. That's why it won't be static. And let's comment this out. Let's remove the breakpoint.
And do it the right way.
What's the right way? I mean, yeah.
So basically, all the Whiteskull object-oriented programming, we are working with a whole bunch of objects, and they have some relationship, or sometimes they don't. But that's how it works. So that's why this is the right way of doing the program. So at this moment when we write, we don't even know what color is that, but once we ask to print it, we will see that it's actually should be blue, right?
Now you see, I'm calling like under this object, this like built-in like custom method here. And because we initiated it here and saved it, the blue one, this method will just print the string color of the car, and the color itself will be dynamic, and it will take the color that we actually set here, and it will print it here.
Does it make sense, guys?
Yeah.
Okay.
Yes.
Well, we cannot call, so can you call this for Evgeny's car, please? Just the next line, maybe. I mean, or this one.
Mhm.
So what's gonna happen? Any guess? It's just null.
Yeah, it's a default value because it was initiated.
Basically, what it says, like, I don't know, right?
Yeah, it says like it's not specified because we didn't specify it here.
And to add the color to Evgeny's car, we have to declare it as a variable, right?
Oh, let's actually do that. Yeah, so let's say first time we print out the color, but then we called Evgeny and he told us that the car, some after, like in the very end somewhere, we can assign the value to Evgeny's car. At the end, is that like somewhere? I don't know, the very last. So at this moment, yeah, we don't know, but then we called Evgeny, let's say, and asked him, yeah, just keep writing after. You can say like Evgeny car dot color, because we have access to all his properties even from here. We can assign it here actually, because color is nothing but just a string.
What's your color, Evgeny? I think it's a kind of black.
It's actually blue, I believe. But we can call it, I don't know, black or
Black and blue.
black, blue, dark blue, something, right? So now, once we assign this color, if we call it again, this time around, it's gonna be actually the color. Make sense?
Yeah.
Yes, thank you.
And then you see it's like purple color. Color is purple color, right? That's why it says it's not the method, it's public field, yeah. And color is noun, right? And print color is verb. So all the methods, they have to be like verbs with parentheses. Those are actions. And fields are nouns. They don't have any parentheses. Those are just the properties.
Mm-hmm. And again, guys, about the structure of the class that we just overviewed today. So this is a class. These three strings, like these two strings and integers, they are called attributes of the class.
Fields, to be precise.
Yeah. And like these two methods, they actually constructors. And this function is actually called a method. And this is an instant method, and we cannot use it without declaring the object. But if we want it, we will need to specify that it is a static. And we won't be able to pass it this way because it won't be changed dynamically.
Yeah, so when we say static, then we say that it can only be one color, but every car has its own color, so the computer confused now. Like, what do you mean by that?
Mm-hmm.
So that's why it's crying.
All
Makes
right.
sense? Is it clear, guys?
Yes.
A little bit?
Yeah, I have actually I prepared some exercises, but because we don't have time to do it right now, I can post it in a channel, so you can train and try to submit it after that. I mean, just for a practice. Right. It should be simple. It's basically asking you to do everything that we did today. Just create instant methods, static methods and constructors, and that calls it. Yep, that's basically it. All right, guys. Do you guys have any other questions in the end before we finish?
No.
All right.
No.
All right, guys.
Yeah, we wouldn't expect you to understand it right away. It took me quite a while.
Actually, this stuff is much more clearer than the previous one. The
Oh, really? Wow.
previous one was much more mathematical.
Yeah. I mean, it's kind of like, it may be also mathematical, like you can also declare the methods within the class and do like the same kind of actions. But it's kind of like more advanced level of the technique that you can use in a programming language. We actually will use all, like, it's not the full OOP that we covered today. We're gonna do like more in the first day. Yeah, I will try to put it like in a simple way, so like hopefully you will understand it. And actually we're gonna use it all in our automation frameworks. So it should be like more clear for you once you will start to use it every day.
Yeah, guys, this thing is very important. Any programming language, any framework will use it. But we're going to use separate classes. So, for example, Selenium WebDriver is going to be our class, and the actual Chrome that you see, the actual window of the Chrome is going to be your instance. Make sense? Or any other browser. But we will have to kind of use the same approach in order to manipulate and automate the test cases. Test case would be actually object as well.
Mm-hmm.
Everything that you can only see, it's always, unless it's a primitive type, it's object.
Yeah. All right, guys. If you don't have any more questions, I will post the exercises in Slack. Like, it won't be part of your homework, but you still have to finish like these two algorithms exercises until the Friday. And yeah, I will see you on Thursday. We will continue to talk about the OOP in Java.
As a short question, should we link together our source tree and GitLab and IntelliJ, or you will show us how to do that?
I will post the instruction how to do that.
Okay,
today.
thanks.
Yeah. But yes, you will need to do that. You will need to link source tree and GitLab. All right, guys. Thank you for joining, and thank you for participating, and thank you for asking questions. We'll see you on Thursday.
Thank you.
Have a good night.
Good night.